Consider this proposition P of n as n can be written as a product of primes where n is greater than 1. So this is the proposition. N can be written as product of primes. Let us prove this by induction. What is the basis case? The basis case, as you know, since n is strictly greater than 1, we start with 2. Right? Now P of 2 will be 2 can be written as product of primes. 2 is itself a prime number, hence the basis case is true. What does the hypothesis state? The hypothesis states that P of j is true for every j between 1 to k, 1 less than or equal to j less than or equal to k. Every number between 1 to k, every number between 1 to k must be true. The P of that number must be true. That is, every number between 1 to k can be written as a product of primes. You see, I'm using strong induction here. The professor has already taught what is strong induction. Now, assuming that P of n is true for every number less than k, less than or equal to k, I'll move ahead to prove P of k plus 1. What is P of k plus 1? It states that k plus 1 can be written as a product of primes. There are two cases here. K plus 1 can be a prime number or a composite number. Let me take the case where k plus 1 is prime. If it is prime, then we are done. If it is not prime, that is, it is a composite number, then let us see how we can proceed. K plus 1 can be written as, since it is composite, it can be written as A into B. A into B are some two numbers whose product is giving me k plus 1. Now, what can these A and B be? The condition goes like this. 2 less than or equal to A less than or equal to B strictly less than k plus 1. Do you see something? A and B lies between or lies in the range 2 to k plus 1. It can take the value 2 but cannot take the value k plus 1. Because k plus 1, we cannot write it as 1 into k plus 1. It should be strictly less than k plus 1. So A and B lie in this range. Now, what am I going to do here? I will use the induction hypothesis, which states I'll apply induction hypothesis to both A and B. What do I do? Which says that P of A and P of B are both true. Did you see why we use strong induction here? We want every number below k, that is less than k, to be written as product of primes, which we assumed in our hypothesis. That is coming to our help here. So did you see the significance of strong induction? When I apply induction hypothesis to A and B, I see that A can be factorized as product of primes and B can be factorized as product of primes. And hence, if it is true that A and B can both be factorized, which means product of primes into product of primes is nothing but another set of product of primes, right? You get another huge expression which is a product of primes. Now that is k plus 1. So we ended up having a prime factorization of k plus 1. And hence, we see that k plus 1 can be written as product of primes. We did it in terms of A plus into B, right? We used the hypothesis that A can be written as product of primes, B can be written as product of primes, and hence we ended up having k plus 1 factored into product of primes. Take a minute to watch the video here and there again and try to understand the proof.